Hello guys, welcome to my mentoring session. Recently, online test, or we can say OA, or online assessment of coordination triology was conducted for off-campus hiring for SDE for 23 and 24 batches. So this was the problem. Okay, and it was a hard problem on special variation of bit, or we can say bit manipulation. So I decided to solve this problem for my mentoring students and record it. Okay, but for this video I'm thinking that it will help the community as well, so I will be posting it on YouTube as well. Apart from that, if anyone is interested in joining my mentoring program for 8 months of DSA and dev training to get into FANG, they can check in the description all the details. Now let's get back to the problem. So guys, I am having three kind of viewers. Okay, one type of viewers are very noob, and the second type of viewers are, we can say, intermediate, and the third type of viewers are pro in coding. So while I try to explain this problem, I will try to explain some basic concepts as well, to make sure that anyone who watches this video gets the full benefit out of it. Okay, as much juice as they could squeeze out of it. So let's get back to the question. So guys, the link to the question code, everything is there in the description, you can check it out. So this is the question. I will explain it in a much simpler manner. Okay, so what the question is. So guys, before discussing the question, I want to clear up something. Okay, I want to clear this one very important thing, and that thing is, the meaning of bitwise AND. Okay, so we need to understand what is bitwise AND. So bitwise AND is basically applied to two binary numbers, 0 and 1. So there are three rules which we need to follow while applying bitwise AND. Okay, this is a very important part of bitwise manipulation. One is bitwise OR, then one is bitwise OR, then bitwise AND. Okay, so currently we are discussing bitwise AND. So if you do, this is the AND sign. Okay, if you do 0 and 1, the answer is always 0. You need to remember this rule. If you do 1 and 0, similarly like above, the answer is always 0. If you do 1 and 1, then the answer is always 1. Always remember these rules. Okay, so if you do 0 and 1, answer 0. 1 and 0, answer is 0. 1 and 1, answer is 1. Okay, this much is pretty much clear. Now guys, I want to explain you how will you tell me the end of this thing should be pretty much clear before I start discussing the question. So say some guy gives you this question and tells you, tell me this answer, 0 and 1 and 0 and 0. So guys, for this the answer will be 0. Always remember, the trick to answer is, if you find even a single number as 0 in the expression, the answer will be 0. I want like you guys to think what will be the answer of this expression. Okay, the question is, find the answer to this expression, 1 and 0 and 1 and 1 and 1. So what is the trick? The trick is that if you find even 1 0, let me write the trick. The trick is, if you find even 1 0, the final answer of bitwise and will be 0. Guys, always remember this very important precious thing. So guys, for this the answer will be what? 0. Okay, now guys, if you don't find any 0, only then the answer will be 1. So what will be the answer for this? 1 and 1 and 1 and 1 and 1 and 1. So here the answer will be 1. Okay, so let me write, if you don't find any 0, only in that case, if you don't find any 0, only then the answer will be 1. Okay, so guys, like whoever is watching this video, I hope they know how to convert the number from decimal to binary, or else you can check the basic stuff online in Google or internet. Okay, so why we do this bitwise and? Okay, let's try to understand. Okay, so say we are given 4, 6 and 7. Okay guys, we are given 4, 6 and 7, and a person is asking us the answer of this 4 and bitwise and of 6 and 7. Okay, bitwise concepts are generally asked in hard OAs and hard CP contests. Okay, hard CP contest problems basically, not hard CP contest. So 4 and 6 and 7. So how will you find the value? The trick is, first we convert them to basic binary numbers. So 4 binary, so the binary value for number 4 is 100. For 6 it is 110. For 7 it is 111. Now we can do the AND of each and every column, and then whatever the final answer is, that is our actual answer of bitwise AND of all these three numbers. So guys, 0 0 1, what will be the answer of 0 and 0 and 1? I told you, if even 1 0 you find, the answer is 0, so I put it this 0 in the third column. Now for the second column, 0 1 1, you find 1 0, your answer is 0. All are 1, there is not even single 0. If you don't find any 0, only then the answer is 1. So for this 1 1 1, the answer is 1. So answer is 1 0 0. So and of 4 and 6 and 7 is what? 1 0 0. Now let's convert it to, this is binary, let's convert it to decimal again. So 1 0 0 is nothing but 4. So basically and of 4 and 6 and 7 is nothing but what? It is 4. Got it, guys? So I hope this much basic concepts are clear, so we can move ahead. Okay, so now uh let me discuss what the coordination OA question is saying. Okay, this is the question, guys. So you are given an array of integers A and many queries in a form of 2D integer array B. In each query, you are given four integers L1, R1, L2, R2. These represent two ranges, one that goes from L1 to R1 and another goes from L2 to R2. You need to return the bitwise XOR of element-wise bitwise AND of integers in these two ranges. First, do bitwise AND of all integers in range L1 to R1, L1 to R1, and let's call it X1. Then similarly do it for L2 to R2, we get X2. Now the answer to this query will be X1 or X2. Return an array with the ith index containing the answer for the ith query. Okay. So now let's me make the question simple. The question is saying that basically you are given a very large array. Okay. You are given two ranges L1 to R1. Okay. L1 to R1. Then you are given L2 to R2. Okay. You are in each query you are given four numbers L1, R1, L2, R2. Now what you are doing is that you have to find the bitwise AND of this range, and of this range. Okay, bitwise AND of this range, bitwise AND of this range. Okay, let's say this is x1, let's say this is x2. Okay, now the question is saying find the XOR of x1 and x2. X1 XOR x2. XOR is also a similar thing like AND. Okay, bitwise XOR of x1 and x2. So this is our question, guys. They are saying that yeah. So guys, the question is that they are saying us that we are given an array and then we are given two ranges, guys. Okay, very simple. We are given two ranges, L1 to R1, then L2 to R2. Okay. So we have to find bitwise AND of this range, bitwise AND of this range. Then whatever we get, we have to do the XOR of these two numbers and output this number. So we are given Q queries for the same. Okay. So for one query, there will be different value of L1, R1, L2, R2. Then for another query, different value, another query, different value. There are Q queries in total. Okay. Always remember this thing. So I hope, guys, this much is clear. So let's move on to the first brute force solution which we can do. So guys, say I'm given a query. I'm given L1, R1 and L2, R2. What I can do, how to solve the question in an easy manner? It's very simple. Just travel the array from L1 to R1 and then L2 to R2. This will, in worst case, it can be as large as the array. So this will take O of n time. So guys, go from L1 to R1 and calculate the AND of all these elements. Okay, in any programming language you can do. Similarly, do this for L2 to R2. So you will get X1, you will get X2. Then what will be the answer? Just output X1 XOR. This is the XOR sign, X2. So guys, you solve the problem in O of n time for one query. For one query, it takes O of n time, but we are given Q queries. So our total time will be what? O of n into Q. It will be O of n into Q. Now guys, O of n into Q is not a good thing. Let me explain why. In our question, n is as large as 10 raised to 5. Q is also as large as 10 raised to 5. So O of n into Q will be as large as 10 raised to 10, and 10 raised to 10 operations is too much. It will not work in just 1 second. Okay, it will not work in 1 second. For 1 second we need a solution which is at least less than equal to 10 raised to 8. Okay, if you guys do CP, you must be knowing this, but now you know that if you know, you know that the answer should be, the number of operations should be less than equal to 10 raised to 8, or else we will get a time limit exceeded error. Okay, so this solution can surely give us some marks in the coordination test. Okay, partial marks, very good. But let's now move on to the efficient solution. We can, guys, exploit and manipulate the fact. Okay, so always remember that in bitwise manipulation you should always do the manipulation. We can manipulate the fact of that we can represent the numbers as what we say. we can represent the numbers in their binary form and get our job done. So guys, what I'm trying to say, that this is our array, right? This is our array, right? If I can find the bitwise end in log time, say I try to find this in log time. So guys, what the question is basically trying to say us that we have this L1 to R1, then we have this L2 to R2. Okay. So yeah, so we have this L1 to R1, then we have this L2 to R2. So what I'm saying, that if we can calculate this in say O of log n time, okay, O of log n time, okay, O of log n time, and say we calculate this in also O of log n time. So if we do this both in O of log n time, then the total time required will be what? O of q into log n, q into log n. Q is what guys? 10 raised to 5. Q is what? 10 raised to 5. So log of n will be 10, and so n is also 10 raised to 5. So if you do, this the logarithmic value, okay, so for this log n, the logarithmic value. So if you take n and you try to take log of 10 raised to 5, it will not be big, it will come to 20. Okay, so 20 into 10 raised to 5 will be less than equal to 10 raised to 8. Okay, it will be some 2 into 10 raised to 7. So guys, what I am trying to say is that if we are able to calculate the bitwise end of a range in less time, then our problem is solved. So guys, let's focus on how we can calculate the bitwise end of a range in very very small time. Okay guys. So guys, here we go. Say I'm given an array 1, 2, 3, 4, 6, 7, 4, 7, 5, 10. Okay. So guys, I have to calculate the bitwise end from L1 to R1. So what I can do is I can represent these numbers in their binary format. Okay. I can represent these numbers in their binary format and my job is done. So let me say this is the zeroth column, this is the first column, and this is the second column. Okay. So this is the zeroth column, this is the first column, and this is the second column. So how does 3 looks in its binary format? 1 1 0. 4 looks like 0 0 1. 6 looks like 0 1 1. Then 7 looks like 1 1 1. 6 looks like 0 1 1. 4 looks like 0 0 1. 7 looks like 1 1 1. So guys, what will be the bitwise end? First I will check how many ones are there in the first row. The answer to this will be even if I find 1 0, the answer is 0. I taught you that trick. In this, the answer is 0. In this, the answer is 0. So guys, for this L1 R1 range, the answer is 0. Okay, because we are getting all 0. Now say the L1 to R1 was from only in this range. Okay, let's ignore the 3. Let's ignore the 3. Then what would be the answer? 0 for first row. Again we are finding 0 here, the 0 for second row, and all are 1. So I taught that trick that if all are 1, if you don't find any 0, only then the answer will be 1. So the answer will be 1 for this. Okay, so for this 1 is here, so we can say so for this the answer will be, the answer is what? 100. If you convert 100 to again decimal format, you will find the answer is 4. Okay, so for this range 3 4 6 7 6 4 7, the answer is 0. But if I remove 3 and try to find the answer from 4 6 7 4 6 7, the answer is 4. So I hope you guys understood how we can quickly calculate. Just convert these numbers to binary, and then for each row, just check how many zeros and ones are coming in this row. If you find even 1 0, the answer will be 0. So how much time did we take to calculate this? We took only 3 operation. We checked row number 0, we checked row number 1, we checked row number 2. So in 3 operations we are able to do this. Okay, So basically we had to make only three columns, or you can say three rows. But if the number is big, say in the array the number is as big as 10 raised to 9, then we might have to make 30 rows. Okay, 30 rows, 1 2 3. So if the number is as large as 10 raised to 9, in binary representation it can go as long as 30. So guys, how much time will it take me to find out how if there is a zero or not in that range? In just 30 iterations, in just 30 iterations. So for any L1 to R1, I can find the answer in only 30 iterations, which you can say as log n. Okay, you can call it as log n or log of a of I, to be very precise, because a of I is the number inside the array. So whatever is the maximum number in the array, I'm only doing log of that operations. Okay, now guys, the question is, how can you know in just one look that how many zeros are there in this bracket? Okay, so guys, this is very simple. What we will do, we'll do the prefix sum of the array. After doing the prefix sum, you guys, I will give you my basic hashing tutorials. Make sure you go through those 2 3 tutorials, then come back to this problem to understand what is the prefix sum concept. What I will do is, I will make a 2D prefix sum array which will tell me the sum of all the numbers in this range. The sum of all the number in this range will be what? 1 2 3. It will be 3. What will be the sum here? 1 2 3 4 5. What will be the sum here? 1 2 3 4 5 6. So whenever the sum is equal to the length L1 to R1, what is the length? 7. Whenever the sum is equal to 7, I will write that answer as 1. Okay, I hope this much is clear. So here nothing is equal to 7, so I write 0 0 0, and you guys know that answer came 0 in beginning. But for this, let's write the sum for this. Okay, for from 4 to 7. So guys, the sum will be, here it will be 2, here it will be 1 2 3 4, and for the last it will be 6. And what is the length from 4 6 7 to 6 4 7? It is 6. Let's check. Whenever the length is matching with 6, I will write a 1, else I will write 0. So this is matching, so I write here 1, I write here 0, I write here 0. So answer is 0 0 1, which is what? Which is nothing but what we say, this is just our that what we say answer. So when the answer is 100, you convert this binary to decimal and you get the answer as 4. So this is your answer. Okay, now apart from that, let's focus on the code. Okay guys, code. Okay, so guys, see, this is the problem. If I run, it works properly, and I will upload this code in the description section as well. So guys, let me explain what we are doing in the code. So first we take the input of the array. Very nice, very good. Then what I'm trying to do is trying to calculate the powers. 2 raised to 0, 2 raised to 1. What is the value of 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5? Powers. I'm trying to calculate the powers of 2. Then what I'm doing is, I'm converting each number to its binary form and putting it in the array if the binary form is 1 or 0. Okay, you guys can check in this for loop. After this, I'm trying to make my sum array, which will give me the sum. Prefix sum array, prefix sum 2D array basically, which will give me the sum of any row in range L1 to R1. Okay, for any row, it can be row number 0, row number 1, row number 2, row number 3, row number 4 till 31. I told you na guys, the rows can be from maximum 30. So for safety purpose, I am making the sums from row number 0 to row number 30. So whenever I have to access the sum, na, any sum, say it is very easy. Like, okay, let me check. So guys, say I have this L1 and say I have this R1. Basically, OA problems are really hard. So sometimes it gets complicated to explain you guys. So I have row number 1. In last example, I only took 2, 3, 4 rows. But now let me take 5 rows. Okay. Now if any guy comes and asks you, what is the sum bro from L1 to R1 for row number 2? For row number 2. So how will you know that? By calculating, by making the prefix sum on this row. Okay. So the name of prefix sum, what will be it? It will be sum of okay, it will be sum of R1 of 2. Sum of R1 of 2. So the answer for this will be sum of R1 of 2 minus sum of L1 minus 1 of 2. So this is how I will be able to calculate the sum of full. Okay. And also the sum of R1 of 2 means the sum of the second row from the very start till here. And sum of L1 minus 1 of 2 means the sum of the second row from start till here. So if I subtract these both, I will get the actual this part which I wanted. So I hope guys this is pretty much clear. So I do that, then I take in the queries L1 R1, L2 R2. I calculate the answer. See guys, I told the answer will be what? Sum of y of I minus sum of x minus 1 I. I check if it is equal to the length. If GG equal to VV, then I add it 1 as 1 to the answer. Okay. Now I cannot directly write 1. So I do the OR of 2 raised to 1. Okay. You will understand it if you know a little of bit manipulation. After that, when I get the answer, I finally do the XOR of two numbers. Okay, guys. So for now, I am just answering this like in my Desi Q&A. So guys, make sure to visit my website Desi Q&A. We are having 1 lakh daily visitors, so we would like you to contribute in the coding questions and answers of this website as well. I do almost daily. I expect others to do as well, to make a very good enriching community. Already we have a community of 1 lakh people, but I wanted to go to 5 lakhs, 10 lakhs. Okay, so per day, yeah. So let me put it as formatted. Okay, it looks good. Let me write it as the best answer. Okay, guys, we are done for the day. All the best. Yeah, let me stop the recording. Uh-huh. Stop.